Hi everyone. So for our project, we decided to create a centrifugal pump to apply the concepts learned in class. For the parts of the pump, we bought a motor kit and tubing from Amazon. The total cost was $23. This chart shows the materials we used and the cost.
To build the pump, we cut a small circle out of a plastic container lid as well as 5 rectangles to be glued together to form the impeller blades. 2 Gatorade bottle caps were used as the pump housing. The motor was glued to one of the Gatorade caps so the shaft could rotate freely on the inside part of the cap, and then the impeller was glued to the shaft. Inlet and outlet holes were made, and the 2 caps were glued together to create our pump. Vinyl tubing was attached as our piping, and the bottom half of the same Gatorade bottle was used as our inlet reservoir.
For the experiment, we performed 3 trials, one at 1.5 volts, 3 volts, and 6 volts to determine the relationship between electrical input and head pressure. This is a video of the first trial at 1.5 volts.
The head pressures, velocities, and pressures above the reservoir and tube are all related by the Bernoulli equation shown. Since P1 and P2 are equal, being the atmospheric pressure, the densities are equal and velocity 1 equals velocity 2. The equation can be simplified to the one shown, which is the equation used to calculate the different head pressures, where HP is the pressure head contributed by the pump, H2 is the head of the water marked on the discharge tube, and H1 is the head of water marked on the reservoir. Initially, we also set out to measure the head loss from the equation derived in class for major energy losses for a smooth pipe, which would have been calculated using the equation shown. Unfortunately, due to unforeseen difficulty of having the pump achieve a complete flow out of the tube at even the highest voltage, we were unable to measure the velocity accurately. This would be the main point focused on in future paths of experimentation.
Here's our trial at 3 volts. As you can see, the head pressure here is much higher than it was at 1.5 volts. Here's the data we collected for 1.5, 3, and 6 volts respectively. As you can see on the graph shown there, as the voltage was increased, the resulting head pressure increased as well.
So this is our third trial with 6 volts, and as you can see, the head pressure is the largest that it was among all 3 trials. So overall, we set out to design a small, economically efficient centrifugal pump to test the head pressure given out and the related electrical input required in order to determine their relationship. Future experiments need to be conducted with a more powerful pump in order to determine the head loss of the straight vinyl pipe used, which is an important factor in efficiency. It was desired to develop this experiment for the less technologically literate in order to promote education and interest in the topic. With more research into the reduction of typically larger, more complex scaled centrifugal pumps into smaller, more economic designs, advancements can be made in more environmentally efficient sources of energy and systems which can be applied for societal use in less resource-rich regions around the globe.